A person carries a plank of wood 2 meters long with one hand pushing down on it at one end with a force of F1 and the other hand holding it up at 50 centimeters from the end of the plank with a force F2. If the plank has a mass of 20 kilograms and its center of gravity is at the middle of the plank, what are the forces F1 and F2? Alright, given length of the plank, meters, and force 1 exerts downward, and that's at one end. And he holds it up with the force F2. That's at R equals to, let's call it R2, at 50 centimeters. Or feet, 0.5 meters. And we are told that the mass of the plank is 20 kilograms. And the center of mass of the plank is 1 meter. Let's call it RW. That's 1 meter. And what we are asked to find is F1 and F2. Alright, so let's sketch this one and see if we can make sense of. So I have a 2 meter long plank. Now one force is exerted downward at this point at one end. Let's call it F1. And another force at 0.5 meter upward. Then there is a mass at middle, right here, the center of mass, and that is mg downward. And the distance, if you assume our axis of rotation to be here, or if we take our axis of rotation to be here, F1 at one end means, let's give it R1 equals to 0. That's the distance from where the force is exerted to the axis of rotation, which is at the same point. And therefore this will be 0.5 meters. That's R1, R2 actually. And the distance from the axis of rotation to center of mass is going to be half of the length. Let's call it RW. Alright, so to find the F1 and F2, we use the two conditions of equilibrium. The second condition states the summation of all torques equals to 0. And what does this mean here? Now, if the axis of rotation is right here, F1 is not creating any torque because R is equal to 0. But the general equation here is going to be F2 times R2. F2 is upward, so related to the axis of rotation is going to rotate in this direction, counterclockwise, meaning it's going to be positive. And mg in this direction downward. This is clockwise, whereas this is counterclockwise. So this is going to be mg times its corresponding distance from the axis of rotation, in this case rw, should add up to 0. And therefore F2 R2 will be equal to mg rw. Just dividing both sides by R2, F2 is going to be Rw over R2 times mg. That is, plug in the numbers, Rw is 1 meter, R2 is 0.50 meters, times the mass 20 kilograms, multiplied by gravitational acceleration, which is 9.80 meters per second squared. That yields 392 newtons. Alright, what about F1? So we know the summation of all forces are equal to 0. This is the first condition of equilibrium. And what forces are up? F2 is up. The two other forces are down. So F2 minus F1 plus mg add up to 0. Summation of all forces equals to 0. Subtract F2 from both sides will lead F1 plus mg equals to F2. Subtracting F2 from both sides and multiplying both sides by -1. And this yields, just subtracting mg from both sides, F1 will be equal to F2 minus mg. F1 will be equal to, F2 is calculated to be earlier, 392 newtons. Mass is 20 kilograms, multiplied by the gravitational acceleration. That's equal to 196 newtons.